This conference will now be recorded.
Well, hello and welcome everybody. This is the Southern California Sector-Specific Drought Outlook. It's June 26, 2025, and I'm Andy Hoyle. I'll present this month's Sector-Specific Drought Outlook. Our effort here is part of our Modernizing Drought Early Warning, where our vision is for drought resilience for the nation's economic sectors. And we'll do so by delivering these monthly sector-specific drought scenarios based on integrated and tailored monitoring and forecasting information. Our mission here is to inform early warning decision making based on co-developed sector-specific and evidence-based drought intelligence. In Southern California, we'll be focusing on agriculture, water utilities, and public health sectors. And we'll be focusing on 9 counties in Southern California. But we also note, when applicable, the conditions over the greater Southwest United States, because the water resources in that region of Southern California is related to the water resources elsewhere within the region. Today is the 26th of June, and we have been conducting monthly briefings for some time now. That goes into later in 2024. When it comes to the sector-specific perspectives, we'd like to open it up to our audience and our colleagues. What questions do you have about drought and your considerations? What topics are you considering regarding drought and its cascading effects? And as always, we are available in this presentation in this forum right here, in addition to being available online. This month's Drought Outlook briefing will be formatted as follows. The first will provide a global perspective, where we'll overview the global conditions relevant to Southern California sectors. We'll then provide a regional perspective, where we'll show conditions in the Southwest United States that are relevant to the Southern California sectors in terms of monitoring information, so current conditions related to drought and forecasts related to drought. And then finally, sector-specific drought outlook for each of the 3 sectors that we'll focus on here: public health, agriculture, and water utilities. When interpreting the sector-specific scenarios, we do assign a confidence to what the scenarios state, and we have high confidence, medium confidence, and low confidence. So with high confidence, we have close agreement among several robust sources of evidence. Low confidence would lead to little agreement among those several sources of evidence. And if we have medium confidence, we feel we have modest agreement. Now, we'll begin with the global perspective, and every so often I'll pause and ask if there are questions from our audience. Now, in terms of the global perspective, we look at the El Nino Southern Oscillation. It's composed of El Nino, La Nina, and neutral phases, and it's related to weather anomalies that are used to predict conditions over California months to seasons in the future. It is a principal source of predictability. That is a source of information for us to be able to identify what the most likely outcomes are for future conditions. Now, relevant to the El Nino Southern Oscillation, neutral El Nino Southern Oscillation is forecast through the end of 2025, though conditions are forecast to be La Nina-like by Southern California's 25 to 26 wet season. This is a very important distinction that we'll focus on in the following, and will have consequences for Southern California. Now, the El Nino Southern Oscillation can be measured in many different ways, and this way happens to be among the simplest. It's what's called the Nino 3.4 index, where we're showing the departure from average of sea surface temperature anomalies that are averaged over the central tropical Pacific Ocean. When conditions are warm, that indicates El Nino, and conditions are cool, those indicate La Nina. Now, where we have been over the last 6 to 9 months is we briefly exceeded the threshold for La Nina. That is, the central tropical Pacific became cooler than average past a certain threshold. But one thing to note there is that this past year's La Nina did not meet the criteria for a La Nina. That was very La Nina-like, but it will not meet the criteria for an event. That's an important point to note, and I'll focus on that a little bit more in the following. This was on the heels of an El Nino that we experienced 2 years ago, and this is part of the natural cycle where we move from El Ninos to La Ninas and so on and so forth. Now, as we go forward over the next several months, there is an uncertain situation as it pertains to La Nina, and I'll explain on this slide. The black line on this time series shows the Nino 3.4 index that was observed since January of 2025 to May of 2025. And you can see here that we briefly went toward a La Nina-like event. What these colored curves show are Nino 3.4 forecasts from many different forecast models. As you can see, the spread across the many different forecasts is very large. That notes a high degree of uncertainty as we move to later in the year as it relates to the Nino 3.4 index and the El Nino Southern Oscillation. The spread here indicating that uncertainty, but the central value there indicating what the most likely outcome is. And as you can see, the most likely outcome is tending toward a La Nina, though not quite reaching those values. That's very La Nina-like and close to La Nina, but not quite. And moving toward the NOAA CPC official forecast, that uncertainty is noted here within the 3-month likelihoods of the Nino 3.4 index reaching La Nina neutral and El Nino categories. So the 3-month season that we are currently in right now is May, June, and July, and a very high probability of being ENSO neutral. Now, as we move toward later in the year, the probabilities of being in a neutral El Nino Southern Oscillation decrease, and the probabilities of a La Nina increase, to the point that by later in the year, they are almost in equal probabilities, La Nina and ENSO neutral, though noting here that neutral is more likely than La Nina. This again being supported by this image right here, which shows that conditions are trending toward a La Nina-like situation, but not meeting that criteria. Now, moving on here into the regional perspective, these are the conditions that are related to the current drought. The first point here is that drought continues across Southern California and the Southwest and has been doing so for about the last year now. The second point here is that for the current water year, which spans the 1st of October of 2024 to June 21st of 2025, that's the day in which we had the latest data available. That period was the 4th driest and 7th warmest such period in Southern California since 1951. And then finally, above average daytime high temperatures and extremely hot days were observed during June 1st to the 21st of 2025. The 21st is the day at which we have data available to us. Now, this slide indicates drought conditions depicted by the U.S. Drought Monitor. The U.S. Drought Monitor is a good first-order approximation of drought conditions, but it considers several different types of drought in their impact. So if you are very focused on a specific sector, you may not focus on the drought monitor, you may focus on another quantity. But it does give a very broad brush view of the drought situation across the United States. Now, in the Southwest United States, there is widespread drought in moderate, severe, extreme, and even some areas in New Mexico, exceptional drought. And this has been a very persistent feature for some time. One thing to note here is on the right, this shows the U.S. Drought Monitor change over the last 6 weeks, where greens indicate improvements to drought, grays mean no change in drought, and the yellows and browns indicate a degradation in drought or a deepening of drought. As you can see here in southeastern California, there's been a little bit of an improvement in drought by about 1 class, and that's related to precipitation that's fallen over the last few weeks. Now, in terms of water resources, we oftentimes look at snow water equivalent. What's been noted over the last several months is a rapid decline in snow water equivalent. And I would invite you to go look at some of the snow drought advisories that have been released by the National Integrated Drought Information System. This plot here summarizes that, where there's just been a rapid decrease in snow water equivalent, and obviously not being able to replenish our rivers and runoff as much as we otherwise would, just because we started off pretty low during the wintertime. There wasn't as much snow water equivalent during the maximum period of April 1st, but then whatever snow did remain melted off rather quickly. Now, fleshing out a little bit more conditions during the water year, spanning October 1st to the near present, that's June 21st. On the left, we're showing precipitation percent of average, and widespread across Southern California was less than 50% of average precipitation. And that starts at the Central Coast all the way down into southeastern California. Now, meanwhile, we've seen very warm temperatures during that period. So temperatures on the order of 1 degree Celsius above average, and even in some areas seeing above 2 degrees Celsius. Some of these areas across the coastal areas have really been stuck in a marine layer for some time. And as a result of that, have seen departures from average that are actually cooler than average, cooler than the long-term average. Now, in order to try to commingle the compounding effects of precipitation and temperature, what we're showing here is a scatter diagram of maximum temperature versus precipitation for the 1st of October to the 21st of June. And noting here that in this curve that we're pointing to here with this arrow, this is 2024 to 25. It's the 4th driest and the 7th warmest such period in Southern California, dating back to 1951. Now, for the 1st of June to the 21st of June, what we've noted here is well above average temperatures in Southern California, and actually throughout the entire state as well. And seeing here that temperatures were in excess of 2 degrees Celsius across most of Southern California. Precipitation on the left is a little bit deceiving. And the reason here is because this time of year in southeastern California, we don't see much rain. But we did see a little bit of rain, and that little bit of rain actually comes out as being about 200% of average. We don't want to indicate that this is a drought buster. It certainly is not. It's actually a very small amount of rain that fell at the same time of year in which we don't expect to see very much. Now, really fleshing out the hot days here, this is the 1st of June, 1st to the 21st of June, and noting days in which we saw temperatures in which 37 degrees Celsius were exceeded. That's body temperature, 98.6 degrees Fahrenheit. In southeastern California, some areas here actually saw temperatures on all 21 days exceed 98.6. But in many other areas, we saw temperatures exceed those values about 16 days. Now, in looking at that as a departure from the average here on the right, noting that this is about 7 days more than what we would expect on the average for June 1st to 21st. So basically, during a 3-week period, we experienced a week in excess, a week more of days in which we saw a very, very warm temperatures, 37 degrees Celsius. Now, moving here into the forecast relevant to drought, this is really based on the perspectives from our colleagues at the Climate Prediction Center, who have a handle on precipitation, temperature, and drought. Now, the first point here is that above average temperatures are forecast through at least the end of 2025, according to the Climate Prediction Center. Second, drought is expected to persist through at least the end of September of 2025, according to our colleagues at the Climate Prediction Center. And then finally, soil moisture will remain below normal thresholds, below drought thresholds through summer of 2025, and most likely remain below drought thresholds through December of 2025. Now, beginning here with the weeks 3 and 4 forecast. So this is valid for the 5th to the 18th of July, and this was issued on June 20th. And the forecast here was for above average precipitation related to the southwestern monsoon over Arizona, New Mexico, and even into southeastern California. The forecasts have only been even more emphatic for above average precipitation in these areas for the first week of July. So this seems to be a pretty robust forecast at this point, that above average precipitation will be observed in these areas. But meanwhile, during this period, most areas in Southern California are forecast to see above average temperatures, with the exception of areas right along the coast. Now, moving in here to July, August, and September, these are forecasts that were issued on the 19th of July, in indicating that there's equal chances of above average precipitation and below average precipitation over the southwest and southeastern California. But meanwhile, above average temperatures are the most likely outcome in Southern California. Now, based on those precipitation and temperature forecasts and other forecasts as well, it follows that drought is forecast to persist and even develop in some areas of Southern California. So these areas of Southern California that are part of our pilot here are noting drought development through this period by the end of September in northern parts of Santa Barbara County and San Luis Obispo County, and drought persistence to the southeast. Now, as we look toward later in the year, and we're going to get into this when we get into each of the individual sectors, that a below average precipitation is preferred over parts of the Southwest United States, according to colleagues at the NOAA Climate Prediction Center. You can see that here on the left, and these are based on forecasts on June 19th. This right here is suggestive of below average precipitation in southeastern California, and there's evidence to support that in the following slides. In addition, above average temperatures are forecast later in the year as well. Now, before we get into each of the individual sectors, now might be a good time to ask if there are any questions from those in attendance. All right, well, hearing no questions, we'll move on here to public health. So in public health, there are two parts to the scenario that we're going to provide. The first is that poor air quality in Southern California is expected during the latter half of 2025 due to smoke from wildfires and other pollutants. We have that in high confidence. And also, anomalous extreme heat, especially in southeastern California, is expected in June to September, and we have high confidence in that as well. We have several lines of supporting evidence. The first is that there's an elevated risk of significant wildland fire potential in Southern California and the entire Western United States for that matter. The second point is that above average temperatures are forecast and anticipated in summer of 2025, and that we've also seen and we're anticipating above average number of days exceeding 100 degrees Fahrenheit in summer of 2025. And then finally, looking toward later in this year, there's an elevated risk of a late start to the 25-26 wet season. Now, beginning here with the air quality index as of this morning on, this should say June 26th. So this is as of this morning on June 26th. We noted that in Southern California, there was some moderate air quality concerns in those areas at the same time as some wildfires that were popping up in that part of the state. Also noting throughout the entire region that wildfires are popping up as well. So in Arizona and New Mexico, this is the time of year when we tend to see wildfires dying down as the southwest monsoon really becomes active, and that's anticipated in the next week or so. So those fires are expected to really die down. But coming into the main fire season, into summer and fall in Southern California, we would only expect to see these fires become more prevalent in space and time. Now, when it comes to increased chances of significant wildland fire activity, we look at several quantities to be able to make that forecast. And vapor pressure deficit is one such indicator. So the vapor pressure deficit is just simply the difference between the amount of water air can hold and the amount of water that the air is holding. So if the temperatures are very warm and the air can hold a lot of water, but there isn't much moisture in it, you're going to have a high vapor pressure deficit. So what this plot here shows is the vapor pressure deficit probability forecast for July, August, and September of 2025. And the warm colors here indicate high probabilities of a vapor pressure deficit forecast being above normal or above average. And you see that here throughout Southern California, even up into Central California, and throughout the southwestern United States. So it follows there that an above normal significant wildfire potential in California exists. And you can see this here based on the National Interagency Fire Center forecast in their predictive services branch, where the reds indicate their above normal significant wildland fire potential. So you see this throughout Southern California in July of 2025. You also see this throughout Southern California in September of 2025. But also noting that across the entire Western United States as well, that significant wildland fire potential does exist. So not only would the local fires affect air quality, but also these remote fires throughout the West that will reduce air quality as the air moves around and into Southern California and throughout the entire Western United States. Now, just to reiterate the point here that the forecast, at least as of June 19th, was not indicating an above normal monsoon for the southwestern United States. This will be updated in the coming days, so the perspective may change, but at least at the time that the forecast was made, there were equal chances of above and below average precipitation, at the same time as having a high likelihood of above average temperatures. I showed this before, but I think it's really important to reiterate that over the first 21 days of June, temperatures were exceptionally hot, and there was anomalous heat in terms of temperature exceeding 37 Celsius or 98.6 degrees Fahrenheit, to the point that compared to average conditions, those 21 days basically saw a week more of really high temperatures than one would expect. Now, another perspective here is showing anomalous heat for July, August, and September. So again, the same perspective. This is 37 degrees Celsius. On the left shows the number of days on average that we tend to see temperatures exceed 37 degrees Celsius. So a lot of southeastern California sees about 2 months of days, 2 months worth of days or 60 days in excess of 37 degrees Celsius. Now, when you consider drought cases since 2000, we're in drought right now, and for these cases since 2000, basically seeing upwards of about 9 to 10 more days a year or during this period in which we see temperatures during July, August, and September exceed those values. So extreme heat since 2000, and that's forecast to continue and materialize in terms of some very, very hot days. Now, here's another perspective. What we've done here is to identify years in the past in which we experienced conditions that were La Nina-like. That is, temperatures in the tropical Central Pacific Ocean were below average, but a La Nina event was not declared. So 2024, 2025 was an example of that. And three other examples since 2000 include 2013, 2014, 2012, 2013, and 2001 and 2002. Now, what's being shown here is the day in which 10% of annual precipitation was accumulated since October 1st. Now, in Southern California, over much of our focus area, we tend to see about 10% of the annual precipitation fall sometime in early December. And that really marks the end of the fire season, the beginning of the wet season. Now, unfortunately, when we saw these La Nina-like conditions, we saw very, very late starts to the wet season. 24-25 is a perfect example of that, where we saw a start to the wet season in early February. And this really allowed for conditions to be ripe for wildfires. And we all point to the LA wildfires as being one of those examples. But there are other examples of that, like 13, 14, 2012, 2013, and 2001 to 2002, where during these La Nina-like events, these La Nina-like situations, we actually saw late starts to the wet season. This right here is a cautionary tale for potential late start and also a potential late end to the fire season too. And this right here finishes up the public health scenario. So I'd invite anybody here in this meeting to provide comments or questions if they have them. Okay, well, hearing none, we will move on here to agriculture. And the scenario is as follows. So anomalous extreme heat in summer of 2025 will hinder agricultural crop, livestock, and workers' productivity, particularly in southeastern California. We're highly confident in that. And also low soil moisture and extreme temperatures in summer 2025 will stress agriculture and livestock. And we have high confidence in that as well. The supporting evidence is that low soil moisture is forecast to continue, that above average temperatures are predicted in summer of 2025, and an above average number of days exceeding 100 degrees Fahrenheit are forecast in summer of 2025. Now, where we're looking right here is the evaporative demand drought index. And the evaporative demand drought index simply quantifies the demand of water by the atmosphere from the land surface and then ranks it in such a way that it compares it to the entire historical record. So when you see values with this really deep red, that means this period for the 1 month ending on June 20th experienced the lowest or the highest value on record, depending on how you want to look at it. Basically, it was the thirstiest that the atmosphere had ever been in areas of Southern California. Now, you might ask, how does the evaporative demand drought index include vapor pressure deficit that you showed before? Well, actually, vapor pressure deficit is one contributor to the evaporative demand drought index. There are several others like winds, like solar radiation, and others as well. But nonetheless, what this indicates right here is that whatever moisture was in the land surface is quickly being robbed and taken from the land surface by the atmosphere, by principally how hot it has been recently. Now, it follows that we didn't have a very good performance in the last wet season, and that temperatures have been hot. So therefore, soil moisture would be quite low as well. And what we're seeing here over Southern California and the southwestern United States are low soil moisture percentiles across almost the entire region. And if you've been noting Southern California and soil moisture, it, it's apparent that there's been a decrease in soil moisture percentiles over the last few weeks in the last month. So we would expect this to continue in the presence of very warm temperatures, which would rob the land surface of its moisture. Now, in terms of forecasts, these are forecasts that are generated by colleagues at the NOAA Climate Prediction Center. And what they do is they include forecasts of the future of precipitation and temperature and other quantities. And they use a starting point of soil moisture and other variables as well. And noting that over the next several months, so this is for the June to November period, that below average soil moisture and low soil moisture percentiles are forecast across Southern California, particularly southeastern California. Now, this picture right here, what it shows is soil moisture behavior for the calendar year. This is for January through December, and it highlights what the percentiles based on 1940 to 2024 look like. And this just shows the range of possibilities here. Now, looking at these colors and the range of possibilities, there's some variability during the wet season, meaning that we tend to see some replenishment of soil moisture, and that when the wet season ends and then the dry season begins, there's a drying of the soils in a natural sense. This is just the normal seasonal cycle of soil moisture. But within that, what we can do is we can plot individual years since 1940. So what we did right here is we took June 26th and we said, when soil moisture is lower than the 30th percentile, what do the traces and the historical traces look like? And this is a way of trying to be able to forecast what conditions would be for throughout the entire calendar year from now. Well, what tends to happen here is with these individual traces is that you don't see any sort of improvement in soil moisture. And the reason for that is because there isn't a precipitation season to really save things and bring things out of drought. Now, even by the end of the year, when the wet season begins in southeastern California, it's still a very unlikely situation that precipitation would be heavy enough in order to replenish the soils. So, and that's why we're indicating and really suggesting here that drought, even if we were to have a really strong start to the precipitation season, that drought would continue. You might ask, well, there's that one trace where we're seeing this big bump in soil moisture during July. Well, that was actually because of a tropical cyclone. And be careful what you wish for, because those tropical cyclones, if they come through during that time of year, they lead to a lot of flooding. And while they may replenish soils, they certainly lead to their own hazards and compounding and cascading effects. Now, I've already illustrated this a few times, but as it relates to agriculture, we've had some very hot days, and these very hot days are pretty hard and stressful on workers. And so folks working out in the field, this is not a comfortable situation and probably makes them a lot less productive, and something that needs to be noted here time and again. And we had already highlighted this before, the main point being that we're anticipating an increase in the chances of really hot days, those exceeding 37 degrees Celsius, based on conditions since 2000 in which we were in drought. Now, this right here finishes up the agriculture scenario. Are there any comments or questions?
Hey, Andy, this is going back to the public health one, but can you revisit drought cases and what you mean by a drought case?
Yeah, sure. So a drought case, what we did here is on this 26th of June, we identified days when soil moisture was below the 30th percentile, and we used 26th of June because that's what today is, and that constitutes a drought case. So we did this in two ways. We did it in the first way, since 1940, we took all drought cases, so that met that soil moisture criteria on June 26th. And on the right here, this is since 2000, and we just took cases since 2000. Did that answer your question?
This is Julie Ekstrom. I was wondering, there was another map that was in the public health part, but this slide also, I didn't quite wrap my brain around it. The one that you were just explaining again, and I think it's probably pretty interesting and pretty important to understand, but since this is also a pilot to on how to communicate it, to normal people, it would be helpful to maybe after you go through everything to if there's extra time, you can explain that to me. The one that you were just showing, but also the drought cases. It was
Yeah.
So this one mentions the drought cases. If we want to remember what slide that was.
Yeah, well, why don't we could do that afterwards. I think we'll have some time, and then we can, I'll describe it and we can discuss it, and actually having some feedback in terms of how to communicate it would be great.
Okay, thanks.
Thank you. Eleanor, did that answer your question?
The question was on behalf of Julie in the chat, so I think we're getting there.
Oh, okay, there is something in the chat. Oh, thank you. It's funny, yeah, it didn't pop up, it didn't notify me, but if I went to the chat, I was able to see it. Yeah, I apologize for not seeing it. Yeah, we'll revisit that in a few moments. Thanks for your question. Okay, moving on here to water utilities, where compared to June 2025, reservoir storage and groundwater levels are expected to be lower in October of 2025, and we have high confidence in that, and lower in June of 2026, and we have medium confidence in that. The supporting evidence is that, number one, a rapid decline in snowpack throughout the western United States, which unfortunately won't be able to replenish our rivers and reservoirs as effectively as during other seasons. Number two, no indication of substantial replenishment due to above average precipitation in the 25-26 wet season. And then finally, colleagues at the Bureau of Reclamation projections over the next 2 years, which don't indicate any sort of recovery. Now, where we begin right here is with reservoir levels in California, and this is from California Water Watch. It's a really nifty tool. What's being shown here in Southern California is the reservoir storage as a percent of average. And if you've been following this over the last number of months, what you'll find is that reservoir storage has declined a little bit. These reservoirs tend to decline at pretty slow levels just because there's a lot of water there and a fair bit of inertia in the system. But there has been a decline just because there hasn't been a high level of replenishment. The same here goes for groundwater levels as well. So groundwater showing a very mixed bag over Southern California, and otherwise showing a decrease. Unfortunately, groundwater levels haven't been able to be replenished with continued use, and as a result of that, we've seen a general decline. Now, just highlighting here the rapid decline in snow water equivalent. Again, this has been really a fantastic decline, fantastic in a bad way, in the sense that we've seen things that we haven't seen before in past seasons just because of the heat and where we came into the season in terms of the low snow water equivalent. But this right here needs to be noted time and again. Now, as we get to later in the calendar year and into early next year, there's a suggestion from colleagues at the NOAA Climate Prediction Center of increased chances of below average precipitation. On the left, this is for October, November, December. This is for forecasts on June 19. And I showed this before, but highlighting once again that precipitation in the Southwest United States is more likely to be below average. On the right, this is for January, February, March of 2026, again for forecasts from June 19, and showing that below average precipitation is preferred in the Southwest and southeastern California as well. Now, I highlighted before La Nina-like conditions, and we had selected seasons and years in which La Nina-like conditions prevailed. Those seasons include 24-2025, which was last year, 2013-2014, 2012-2013, and 2001 to 2002. So what we did is we looked at the precipitation percent of average based on conditions from 1951 to 2024 for each of these 4 seasons. And what we found there, unfortunately, is that precipitation was below average in southeastern California in all of these cases. Now, these are the cases that have similarities with what we were forecasting the La Nina-like situation to be. So this right here is a first guidepost for what conditions, at least in terms of precipitation, may be for the entire wet season. And the parallel picture to this is the start of the season that I showed a couple slides previously. Now, the colleagues at the Bureau of Reclamation, they put together these projections of Lake Powell end-of-month elevations. And there's a pretty big spread in the elevations for these forecasts going forward. There's a really optimistic situation, and that's shown in the blue curve, that blue dash curve right here, where they show a probable maximum inflow with Lake Powell releases for 7.48 million acre feet for water year of 2025 and 9 million acre feet for water year of 2026. But then there are some more pessimistic situations. The first is that the most probable inflow at Lake Powell, based on historical conditions, and releases of 7.48 million acre feet in 25 and 26. So that indicating a decline from conditions where we're at now, an increase in April, May, and June of next year, and then a decline thereafter. And then there is the really pessimistic situation where we have releases of 7.48 million acre feet in 25 and 26. But unfortunately, the weather conditions during this time are more pessimistic. And as a result, these pessimistic conditions really lead to a situation that is not good. We'll probably fall somewhere in here between the green and the red. It's just a matter of where. And unfortunately, that's not a very optimistic situation, but unfortunately, one that is somewhat of a reality. So this is the water utility scenario. Are there any comments or questions? Well, hearing none, I thank you all for joining today, and we hope that you found it to be useful. And Julie, we can stay on a while longer and discuss a little bit.